Hello, hello, hello. Good to see you all. Good catch, man. Good throw. We are gonna change up just a smidge. Not because anything's bad. So I'm gonna be gone. I won't be in this class tomorrow or Friday. I have the same son both days. Mr. Dirtinger's father, who's also Mr. Dirtinger, will be here. And so I wanted to make sure I had this concept covered. And I think you guys will like this concept because it's going to, I think, really make sense. And it has to do with pattern graphing. It's a neat thing. It's a neat tool to use when graphing parabolas. So can I just dive right into it and see how we do? All right. So looking at the very first problem is y equals x squared minus 4. You with me? Our a value is 1. Our b value is not there, so it's
0.
0, and my c value is negative 4. So finding my vertex is still going to be the same way. So I'll plug in. So I'm going to get negative 0 over 2 times 1. So I'm going to get 0, negative 4 as my vertex. I went through it kind of quick, so does my terminology make sense?
Yes.
We good? Okay, so it's just finding the vertex. The axis of symmetry, pretty easy. It's going to be x is equal to 0. Okay, so we can actually at this point go ahead and start graphing these problems. So let's make some straight edges. See if we can make this work out for us. Okay, so I'm going to plot 0, negative 4. Everyone feel good so far?
Yeah.
Any part of this that didn't make sense so far? So we're going to do something called 135 graphing. 135 graphing doesn't always fit for all the values, but sometimes it will. Okay? So we're going to use 135 graphing. Item 1. What is my A value right now?
X. 1.
1. Okay? So 135 is going to work very well. If it's not 1, then I'll show you what to do in this case. But being my A value is 1, we're going to do this. So see if you can follow what I'm going to do. I'm going to go right 1, up 1. I'm going to go left 1, up 1. Okay? My next move is this. Ready? The next number of 135 is? 3. So from this point, I'm going to go right 1 and up 3. And from this point, I'm going to go left 1, up 3. Still with me? What do you think I'm going to do with that last point?
Go up 5. 1 over.
Yeah, so from the red dot, I'm going to go over 1, and I'm going to go up 5. And here, over 1 and up 5. Done.
That's the
Parabola. My dark line there is my axis of symmetry, and I just graphed that parabola. Did I factor it? No. So let's see. The only thing that's kind of the same is I found the vertex of normal y, bless you, by negative b over 2a, plugged it in, and then found the axis of symmetry, and then I pattern graphed. Huh. Can I move to the next problem?
Yes, you can.
Okay. The next problem, it's 2x squared plus 4x. Is that correct?
Yeah.
y equals 2x squared plus 4x. Okay? So let's start out like any other problem. What's my a value?
2.
2. What's my b value?
0. No,
0. Is it?
It's 0. It's 4.
It's 4. What's my c value?
0.
0. So be careful on that. So my a, b's, and c's are listed. Okay? Yeah.
Wait, why is it B4?
X.
Because the x value is the b value. Because remember the basic form of this is y equals ax squared plus bx plus c, where a is attached to x squared, b is attached to x, c doesn't have a letter attached to it.
Oh, and the last one didn't have an X, so it's
All right, so finding the vertex, negative b over 2a, comma, plug in, yes?
Oh, it's just
Negative 4 over 2 times 2, which is 4. We're going to plug it in still. So that's what, negative 2, comma, if I take negative 2 and plug it into x squared, what do I get? 4.
8.
Times 2,
8.
8. Negative 2 plugged in here, 4 times negative 2 is?
Y equals 16.
Plug negative 2 in here, what do I get?
8.
negative 8.
Negative 8.
Negative 2. Oh my god.
What's wrong?
Oh, I thought it was positive 2.
8 minus 8 is?
0.
0.
Yeah, that's fine.
Spider. Spider.
I got 2 of them.
Yes, it's
That was 5.
I like the black one.
Nah. All right. So let's think about this. My 135 will work, but what's my a value?
2.
2. So I'm going to change my 135 to this. Why do you suppose I did that?
Okay, so it's 2, so you gotta
Yeah,
make it.
I'm going to grow at a scale factor twice as fast now. Because my x squared value, my a value is 2. My 135 is no longer 135. Now I'm still going to go right 1, and right 1, and right 1, and left 1, and left 1, and left 1. Bless you. But I'm going to allow it to grow vertically a little bit faster. So let's see if we can get this graph up here. All right. Negative 2, 0. Yay?
Yeah.
Okay. Axis of symmetry is? X equals negative 2, right? So that's kind of this. Right? All right. So from that point, remember I'm using these now. I'm going to go right 1 and up.
6.
What's the first number?
2.
So I go left 1 and also up 2. Okay? From that point, from here, I'm going to go right 1 and up how many?
6.
6. Have I kind of outgrown this chart?
Yep.
Yeah. That's okay. Remember I said it won't always fit. There's my parabola. So the a value dictates whether it opens up or downward. If it's negative, it goes down. If it's positive, it opens up. The a value also dictates how fast our parabola is going to grow. Okay? All right, Ben?
Yeah.
Okay. Need a spider to chase that fly. Just swallow. All right. I'm going to change the third problem a little bit. That's on your page.
I just started doing
Take a look at your Take a look at your values and what I changed.
it. You made it negative.
So take a look. Make your changes on yours appropriately on that third one. What are some things that kind of pop out to you on this problem a little bit more?
It's going to open down.
It's going to open down. How do you know?
Negative A.
Negative A. Got it? All right. So what's my A value? Okay, B is
4.
cool. C is
-4.
okay. And again, we're not using C right yet, but it's okay that we're labeling it. Everyone okay with where I got those values?
Yeah.
Okay, negative B over 2A. Plug in, right? Okay, so negative B over 2A. 4 over what? Yeah, buddy. Negative 4 over negative 2. What's negative 4 over negative 2? 2. And then I'm going to take 2 and plug it back in. So I have negative 2 squared plus 4 times 2 minus 4. Why do you think I didn't put this negative inside the parentheses? This negative is going to come along to the right. It's always going to be there. So 2 squared is 4 minus in front. So I get negative 4. 4 times 2 is 8. Minus 4. Now look at this one. It also is going to fall right on the. Okay. Axis of symmetry.
2. X equals 2.
Cool. Let's go graph it. Two zero. My 1, 3, 5 is going to be what now? What? There you go. These are all negative now. Why are they negative? The A is negative. I have an A value of negative 1. So, on here, I'm going to go right 1 and down 1, left 1 and down 1. Correct? What else? What's next? What do I do from the red point?
Go right 1.
Right 1 and down 3. And then left 1 and down 3. I guess I could even go a little bit further. We have a little bit of room. And then I'm going to go right 1 and down how many?
5.
That's correct.
Pretty close? Was I using a ruler? So I'm going to be off a smidge. Axis of symmetry is doing this, right?
Yep.
Golly. This is so much easier than, you don't get it?
When do you decide that one of them is 1, 3, 5, and the other one's 6, 6?
The A value dictates it. If A value is 1, 1, 3, 5. If the A value is, so let's do this real quick. So if it's just x squared, we're going to use 1, 3, 5. But this is going to go 2, 6, 10. This is going to go
3, 9, 15.
what's this one?
4.
Up, another trick.
Negative 5.
Negative 5,
Negative 15.
negative 15,
Negative
25. That make sense? Huh? So 2 times 1, 2 times 3, 2 times 5, 3 times 1, 3 times 3, 2 times 5, 4 times 1, 4, 3, 5, 5, negative 5, 1, negative 5, 3, negative 5, 5. Okay? Huh. I go to the next problem. Have I used the F word yet? Factor?
Better use a fraction.
Who's gonna say it?
Say it!
One day eventually.
Let him say it.
Oh, fraction.
Let him say it now. Yes.
A value is what? Yeah.
It's actually
2.
Yeah, I'm just showing you another one that I think you're going to like this method. It's really quite simple. Watch. You're going to watch all the way through this. Ready? You're going to talk me through this one all the way through. Andrew, hold your hand. What? All right. Everyone okay with A is 2, B is 4, C is -3?
Yes.
Everyone okay?
yes.
So let's find the vertex like normal. -b over 2a. Comma plug in. Okay. So I get -b over 2a. Is my math right so far?
Yeah.
We still okay?
Hold on. Okay.
All right. Where's that -1 getting plugged into?
X.
Up here. Here and here. So I have, I'm going to do this kind of sideways. 2 times -1 squared plus 4 times -1 minus 3. What is this answer?
2.
Just 2. -1 squared is 1. 1 times 2 is 2. What's this answer? -4 minus 3. So 2 minus 4 is -2. Minus 3 is...
Wait, don't we square it?
We already did. That gave us +1.
Oh, yeah.
-5.
-5? -5? We good? Casey, you still with me?
Yeah.
All right. Axis of symmetry. X equals -1. Casey, still with me? Yeah.
Yeah.
Oh, yeah.
Oh, no.
Okay.
Oh, straight.
So all I'm going to do, because there's a straight.
Oh, I was like, this is...
I'm not that
Oh,
good,
you
huh?
did that.
All right. -1, -5. -1, -5. Vertex, yes? Yay?
Yeah.
All right. It's opening up, correct?
Right.
And I would use the 1, 3, 5 pattern, but something's going to be in our way. What is our pattern going to be? What's my... It will indeed. What is my growth pattern going to be? Not 1, 3, 5. It's going to be 2, 6, and 10. Why is it 2, 6, and 10, Mac? What did I multiply 1, 3, and 5 by? 2. Where did the 2 come from? What value is 2? Axis of symmetry. What value is 2 on the original problem? Right? So my A value is 2. So this is my multiplying factor of 1, 3, 5. If it's a 1, you use 1, 3, 5. If it's a different number, you multiply 1, 3, 5 by that number. That's why we're going to grow at 2, 6, 10. It might not all fit. Agree?
Yes.
Okay. So here we go. I'm going to go right 1 and what?
Up 2.
Up 2. I'm going to go left 1 and up 2. Casey, are you okay with how I just established that?
Yeah.
All right, ready? Next set of points, and we might be only able to get this next set in. So from this blue dot and this blue dot, I'm going to go right 1 and up how many? 6. Look at that. From this dot, I also went left 1 and up
6.
6. I probably can't squeeze any more because my next would have been going right and up 10, which might go off the graph. But that's okay. Hey, if I'm pattern graphing this way, let's see, hang on. Talk to me.
Oh, what if it's 3x squared?
Oh, you triple these. 3, 9, 15. All right, hang on real quick. If I'm pattern graphing, and I know that's -1, -5, what do you think this point is right here? I went right 1 of -1. What's right of -1? 0. Okay? If I went up, how many did I go up? I went up, how many? 2? If I go up 2 from -5, what do I get to? Okay, so this point over here is also going to be the -3, but I went left. I went left of this, so what did I get to if I went left of 2? Okay, shh. All right? Think about this last one. If I went to the right of 0, one spot, where do I get to in the x? 1. If I went up 6 from -3, so -2, -1, 0, 1, 2,
3.
what's this point then?
-3, 6.
Almost. -3 is correct.
It's going to be 1.
Oh,
-3, 3. We had gone up 6. You're totally right. But we had to count up for that. Casey? Easy enough? Axis of symmetry. Dang. This is a little different, but kind of flows. Kind of flows. All right, guys and girls, I want you to try the next one, which is y equals what?
Negative x squared plus 1.
Cool. Try it. Try it. Try it. List your A, B's, and C's.
We're doing this by ourselves.
Cool. B is 0. I like it. B is 0 on this one, guys and girls. C is 4. And then you should be able to find the vertex pretty easily. Megan, which way are we growing on this one? Negative, right? I didn't know if that was you. Tristan answered. Negative. So we're not going to go 1, 3, 5. We're going to do what? Negative what? -1, -3, -5. Good. Watch the language. What do you think?
That's what I got.
Do you think if you have, including the vertex, 7 points as part of a parabola, do you think that's good? You think that's good? How many points do we require for a straight line?
Just
2, right? So 2 was good enough for a straight line. You actually want to define 3 1 being the vertex of a parabola to define a parabola. And we have 7 defined, including the parabola, or including the vertex. Thank you. Yeah. 45. Let's try let's try the next one, the y equals negative 3x squared one. See if you can get it. See if you can get it. You guys doing it? Some of you are talking, Ben. Is that my growth factor? If so, what happened to the 1, the 3, and the 5? By what? Negative 3. What do you know about this parabola? Opens down. Why does it open down?
Negative.
Negative. Good. Yeah, if you go all the way down, absolutely. Absolutely, good call. Impossible concept?
No, not impossible.
Seem a little better? Yo. You want to work that hard? Go for it. So the reason I've shown you 2 ways is you guys have just witnessed there's one student in this class that sees the first way better. Is there something wrong with his head?
Yes.
No. JC, you got a beautiful mind just like everyone else in here. Cool?
A little less beautiful because like he wants to do more work, but you know.
Hey, you know what? There's nothing wrong with hard work, right?
Yes.
Huh. So, guys and girls, we have just a few minutes left. And the problems themselves, they're not impossible. Last one I want to do is y equals 5 minus x squared. And the reason why I want to do it is it's out of order.
Oh.
It's out of order. So something that y'all need to know. Could I write this problem to be this? Yes? Where did the positive 5 come from when it's just 5 sitting there? Yeah, flip-flop around. You have to realize if 5 sits there, it means it's positive. There's not a sign with it, so we know that's where the positive comes from. So a few things about this problem. If you went quickly about it, you could go, my vertex is at 0, 5. So Casey, by all means, if you feel that you want to plug into a grid where you have a number to the right of the vertex and another number to the right, and then one to the left and one to the left, absolutely go for it. Cool? Tomorrow, there's going to be 4 problems given to you as homework. Now, guys and girls, in order to make parabolas kind of fit, some of the problems will look very similar. They might have one sign different, but you have to kind of use some of the same signs. There are 4 problems on here. Mr. Dertinger will go over the 4 problems with you. You will then do 4 problems, hopefully get done in class tomorrow. And then the following day, Mr. Dertinger will go over those 4 problems with you and give you 4 more problems, hopefully that you will get done in class. There still is, guys and girls, on Schoology, there's some things coming due Friday night, okay?
Is that just 6 and 7?
Yeah. I've been working on 8. I haven't made it yet. It's like halfway done, so it's not assigned to you yet. So guys and girls, this is what I'd like. Still with me in this adventure?
Yes.
So, the homework's from Wednesday, the classwork on Thursday, the classwork on Friday. I'd like to see them all put together. So when I come back on Monday, I will see that you have your 3 sheets. Now, guys and girls, this is what gets really tough. If I'm gone Thursday and Friday, I come back on Monday, and you're like, I didn't get this, and you have nothing, I'm going to request a parent-teacher conference with your dean, your assistant principal, your parents or guardians, and you to point out what you are not doing. Because I have the video here. It's on YouTube. Okay? Make sure you get it. Do it. Don't let me come on Monday and you have Wednesday and Thursday and Friday blank. Like, I just get it. That means you're not even trying. You're not even attempting to do anything. And shame on you. Got it?
Yes.
I'll be in my office.